Okay, I'm just going to extract this third wire. There's a live, neutral, and ground in AC. And I'm removing the ground. I'm keeping the live and the neutral. So I need 2 wires for my DC fan. Okay. Beautiful. Okay. Okay. Um, by the way, guys, I just want to make an announcement. Uh, I came up with a tremendous shortcut for Adam. I'm actually not going to build his spine. I'm going to let him build his own spine. So I'm just going to put basically a stick as a spine, connect all of his rib cage to that stick, which is a placeholder spine. Once Adam's done and his arm is working, he can cut away that stick, replacing it with vertebrae, systematically upgrading to a proper spine himself. I shouldn't have to do that. Adam should have to do that. So that's going to be a huge time saver. No longer do we have to worry about making these vertebrae. Now we just have to worry about finishing up the rib cage bones and then the scapula and the collarbone and connecting the arm to that, and then it's off to the races with all the electronics and stuff. So that's a huge time saver for us. it has nothing to do with laziness. It's the less work I do, the more work Adam does of his own construction, the faster his construction gets done. Because now I'm not wasting weeks and weeks or months and months trying to make him myself when he can make himself. It's just more efficient to have the robot built by the robot. As soon as he's physically capable of building himself with enough components to make it happen. And I just realized he doesn't need to have a fully articulated spine to be able to build the rest of his body, including building his own spine. He doesn't need it. So he's not going to have a fully articulated spine now. So, yeah, I'm disappointed you guys didn't come up with that first, but I thought of it first, so I guess I'm the most creative one here. And that's going to be a huge time saver. That means we get to motion and logic and AI all the sooner. It's a big win for us. Mm-hmm. It will shave off probably like 4 months, 5 months of the build time, which is huge. I mean, that's just something I came up with in the shower just now. It saved me 5 months. 5 months at my current pace of only working on the robot a couple days a month. Like, obviously, if I was working on it every day, it'd maybe only save me like 1 month or something. Not 1 month. It'd save me like 10 to 12 days. It's going to save me 10 to 12 days of work, which equates to 5 months of work, since I only work on the robot once every couple of weeks. Like, does that make sense? If you don't work on the robot every day, and you only work on it once every 2 weeks, then every day of working time on it amounts to, or every 2 days of work equals 1 month if you only work on it twice a month. How is it more efficient to get a robot to build itself? Well, if your goal is to build a robot that's capable of building robots, then you already know you have to program enough AI and capabilities into the robot to be able to build robot parts and assemble them and stuff. So it stands to reason that if you're already going to be doing that work and investing that time to generate those capabilities in its software, then why not do that work and invest that time up front as early as possible so that with just minimal number of body parts, the robot can build the rest of his own body, saving you a ton of time that you would have spent doing it yourself, when in fact if you would have spent more time on the software, he could have done it himself once he had those software capabilities. So I'm building the minimum amount of the robot for him to be able to build the rest of his own body, and then I'm going to focus on software that will enable him to actually build it. And like I said, that's way more efficient because I was going to add that software anyways, because the robot was going to be able to build more robots anyways. It's just a little outside of what you'd expect to have the robot build himself. Normally you'd think you'd build the first robot and that robot would build the second robot, but I just realized, well, if he's going to be able to build a robot, why doesn't he finish his own build? And so that was just thinking outside the box. It's way more efficient. What is going to be so good about this software that he builds himself? Just really good computer vision, really good eye-hand coordination, really detailed instructions on the software end given by me for how he's to do various things and use various tools. It takes a lot of time to create that level of detail in the software for him to be able to accurately do complex tasks like that. But like I said, if your goal is to build a robot and that's it, sure, forget trying to get him to build himself, just build him yourself. If your goal is to build a robot army, and so you're going to need to build the robots who can build robots, then why build the first robot to its entirety yourself when you know that that robot will someday be capable anyways of being able to build a whole robot, so why not have him build himself right away to save you time? I mean, it's very logical. Like, whatever time it would have taken me to personally build his build, and he does it instead, is time saved. We can all agree on that. I mean, you don't really have to explain it further than that. It's time saved. And if your argument is, well, that'll take too long to give him those capabilities to be able to build the rest of his own body. Well, that's not true, because I was going to do that anyways, so that he could build the next robot, and those two robots build two more, and so on, until I have a whole army of robots. So I was going to make a robot that can build robots anyways. Why not do that to save time early on? I mean, what you guys would otherwise be suggesting is I take all the time to build all the bones in the whole body myself, get the robot walking, get him doing all kinds of stuff, and then someday, maybe, eventually, teaching him how to build another robot. Well, I don't want to do it that way. I want to teach him how to build robots right off the jump. Because for a robot to build other robots, that's the most valuable thing that a robot can do. Because if the robot can build other robots, then I gain the value of each robot he builds is worth, $1 million or $2 million. So why teach him things like making a sandwich when I could teach him something that's really, really profitable to me, which is building more robots? I'd rather jump straight to the very valuable thing that he could do for me. sooner he can do that, the better. I can't think of a single more valuable asset than having another robot, so get him doing the most valuable thing he can do. That's efficient. Okay, let me go ahead and plug this cord into the fan. Okay. Got our fan here. And now we got it plugged in right here. Now on the other end, we're going to hook this up to the battery and see which side is positive and which side's ground. Okay. My left hand is positive, so the green one is ground. Okay. It's easy to remember. Let's get our Dean's plug out. Define software. Software will be a huge C++ program that teaches the robot how to understand the information fed in through the webcams and make sense of all the different motors and inverse kinematics needed, and make sense of all the sensory input like motion sensors, not motion sensors, pressure sensors, aka strain gauges, and read in the battery voltages and switch certain batteries into charging mode or battery mode, and all that good stuff. My gut's not getting big! My robot's a boy. I don't want to use library computers. Okay, so looking here. The smaller side turned sideways is red. Okay. You guys don't realize I'm a software writing genius. One of the best software developers on earth. Probably the best, actually. So, creating the software or the brains of the robot will be where I shine the most. Which is probably hard for you guys to believe, since creating the bones and all the other engineering aspects, I've already been the best in the world. So it's probably hard for you to believe that I can be not only the best hardware engineer, but also the best software engineer and electrical engineer on Earth. But, you know, that's the case for me. I was just born that way. I can't help it. And I say that with all humility. Okay. Perfect. Guys, I'm getting to be a beast at soldering Dean's plugs. Look at this fancy stuff right here. Yeah. How do you like them apples? That's world-class soldering right there. World-class. You won't see a better soldering job on Earth. Not possible. Not even a machine can solder better than me. I say that with all humility. It's a burden, really, to be this good. But somebody's got to be good, right? I mean, not everybody can suck at everything. Some people have to be great at everything. I'm one of those. Some people said you can be a jack of all trades, master of none, but I decided that didn't sound satisfactory to me. I decided to be a jack of all trades, master of all. So that's what I ended up doing. It's a lot more satisfying, in my opinion. Okay. And then this guy. It's working. Okay. Beautiful. So, so that's something off the to-do list, boys. That was the second fan. Now they both have nice long cords to them. We'll just put away now everything.